And there is our tank. So you see a tank right there. Welcome back to Arcade. I am Super Tommy, and in this video, we're going to take a look at Phaser 3, Matter.js, and ECS. It'll be similar to our ECS videos with Phaser 3 and Arcade physics, except we're going to use Matter.js physics. Now, if you enjoy our ECS videos, be sure to like and subscribe for more videos on making games with Phaser 3 with ECS. It is also the best way to support the channel. First thing we're going to do here to start is create an entity. So now our entity is this tank. That's that E that you see next to this blue tank. And our entity is going to have two components. So that's the position and matter sprite component. Now let's take a deeper look at these components. So our components are going to have different properties. So our position component has two properties, X and Y, just to show where the tank should be in our game. And then our matter sprite component is going to have a property for texture, and that's going to be a number. And that number is going to index into an array of Phaser 3 keys for the images that we load so that we can use them in our sprite. Now let's check that out in code. All right, we are in our Matter ECS scene here. So we've gone ahead and created the basics of a Phaser 3 scene with some of the basic setup for a bitECS world, or how the bitECS library wants you to set things up. For a full setup on how that works, do check out our Phaser 3, ECS, and Arcade physics video. But we're going to go through a rundown here real fast. So we're importing from bitECS here at the top. You can see this. We're going to use these functions to create a world, add entities, and then add components. And then we have some components that we just talked about that we are going to show you. We've pre-made them, they're very simple, and we'll show that to you. So this setup with the textures, enums, and the texture keys is what we mentioned about the matter sprite having a texture property that's just going to be an index, a 0 to 4 here index into this texture keys array. So in our scene here, basic setup, the key to note here is we're going to create a world, create a tank entity, and then add those two components to our tank entity. Now, one thing different here, of course, we got to create our matter sprite system at some point. But one thing that's different here is we have a pipeline. We'll talk more about that when we create our system. But just note that this is a way to run a bunch of systems together. Okay, so let's look at our position system and our matter sprite system real fast. So here is our position system. So it's very simple, like we discussed previously. It has two properties, X and Y. We use define component here from bitECS to define this component, and then we give it a type for each property. Now in bitECS, everything is a number type, so that's either integers or floats. So this is this is just how bitECS can create a contiguous block of memory for these typed arrays. And it's a faster iteration through it instead of having a normal vanilla JavaScript array. So these are all going to be, for example, this is a float 32 array. It could be an integer 8 array or an unsigned integer 8 array. This is just how bitECS works for maximum performance. Now let's go back and look at our matter sprite component. So that's very similar to our position component, except it only has a texture property. And the type here is unsigned integer 8. So in our position component, let's go back here, you saw that we're using float 32, or that's F32, just because in our X and Y we can be at position 100.038 or 105.5. So there's more granularity that we need for X and Y, versus in our matter sprite component, these are just going to be whole numbers starting at 0, never going negative. We can't negative index into an array. So we start at 0 and going to whatever max for unsigned int 8 is. I don't remember, but it is going to be big enough for our purposes here, which is only going to be an array of, I think, 5 total entries. So let's go back to our scene. This is our Matter ECS scene. Now, I'll just briefly show you our main.ts actually. So we just have a basic setup here. We have our scene. Now, one thing do remember to do if you're using Matter is in the Phaser 3 game config here to default your Matter, your physics engine to Matter, and then set your Matter properties here. We've turned debug to true, and we've turned off gravity. So that's gravity Y0. So now let's come back here. So let's make a world. So in bitECS and in most ECS systems, you're going to need to create a world to add all your entities to. So let's do that. So we actually have, I think, a class property called world, and we're going to do create world. All right, great. Next, let's make an entity. So let's call this tank, const tank add entity. So these are all bitECS functions that we're importing at the top and calling here. We're going to give it a world. And then we're going to add components to this tank. So let's do add component. And we're going to add the position component first. Oh, sorry. The first argument in this add component function is the world. So this dot world, then the component, and then the entity ID. That's EID. That's going to be tank. Now we want to set the value of our x and y for our tank, and we do that by using the component. So component dot x, we're going to index into the x value of the component for the tank ID. Let's just say 200, and position dot y, same thing here, 200. So how this works is the components have an array for each property that you created, so that x and y previously, and each entity is an index inside that array. So this is of course different than the inverse of it, where you create a tank class and then each class itself has the x and y property, and then you can have an array of tanks, for example. So this is inverted, where you have an array of the x property and then each tank is an ID in that array. So that is the difference between ECS and more traditional object-oriented programming. So this may be confusing at first, but you'll get used to it once we keep going. So just know we have a position component, we have x and y values, and we have an array of those values, and each entry in the array belongs to a entity. In this case, at index tank, which since this is the first entity we've made, is going to be 0. At index tank, we're going to set the x and y values to 200, 200. Now let's do a similar thing here for our Matter Sprite component. So now let's do add component, this dot world Matter Sprite. And again, the EID is tank. Now for Matter Sprite, we want to give our entity an actual texture to use. Also index into tank, or index into our texture array at index tank. And so what we're going to use here is textures dot, let's say, tank blue. Now this is just a convenience that we've done. You can also simply do this, right? And then later it just has to match up in our system, which we'll talk about, match up to the index in the array here. It's got to match up to this array. So 0 is blue, 1 is green, 2 is red, for example. So we just made it a little easier to redo in your coding to make it an enum. But you can also use raw integer numbers if you so desire, because that's what's really happening behind the scenes anyway. So that's adding the component to our entity. Now that we have our entity created and we've added components to it in the code, we're going to need to create a system to operate on any entity that has those components. So we're going to create a Matter Sprite system like you see here. That's the S for system. It's going to operate on any entities that have the position component and the Matter Sprite component. So now let's see how that looks in code. Okay, now it's time to code our Matter Sprite system. So here in our matter.ts file, this is just the file we've created to hold all of our systems for Matter.js with ECS and Phaser 3. So we've just added some boilerplate here that you're going to need to do. So that's importing Phaser, importing some functions we're going to use from bitECS define system that we're already using here to create an empty system. We've got define query, enter query, exit query. We're going to use those shortly. The two components that we talked about that we're going to need. So this system is going to look at any entity with these two components and then operate on those guys. And to store our Matter sprites, that we can reference it in other systems later, we're going to create this map, which maps the entity ID of the entity that this Matter sprite belongs to. So it's going to be, tank, if it's 0, and then the Matter sprite we create for the tank, for example. So let's look at our create Matter sprite system function. So this is a function that returns a function effectively, because define system will itself return a function, which is a system. But when we call that system later, it's called as a function. But all that really matters here is this is a creation function that then creates a system. So we're going to call create Matter sprite system in our scene. That's Matter ECS scene. When we later, after we create we add the logic and the code here, we're going to call this create Matter sprite system. That's going to generate a system for us that's going to be then used. So we're not using define system directly here. We're creating a function that then returns what define system returns. All right, we're doing that because we need a bunch of queries and other setup before we actually define the system, including getting the Matter factory. This is the Matter physics factory to create Matter sprites, and then our array of textures. So a lot of talking here. Let me just show you in the code. It'll make more sense, I hope. All right, let's see. First thing, we actually need to make our base query for querying all the entities that meet the predicate that they have the position and Matter sprite components. So let's do const query define query, and we're going to give it a list of components that we want, which is going to be position and Matter sprite. So this query is going to be for every update tick. We are going to get all the entities that adhere to this query or this rule that they have the position and Matter sprite components. So, but we don't actually care about that in this system, but we do need that query to get our enter and exit queries. In this case, we may not need exit query, but we'll go over what that does. First, let's do our enter. So let's just do query enter and do enter query. So this may be confusing. We can call this, we'll call this on query enter. I'm not sure that's better, but we'll just discuss. So enter query, pass in the query. So what this does is this on enter query function, when called on each update tick, is going to give us all the entities that just got these two positions, these two components added to them. So for example, let's do this. So const enter entities. So these are the entities entered that just got these components added to them on query enter. Right, pass in the world. So this is going to be an array of IDs. That's why they're numbers. So let's loop through them and enter entities dot length plus plus I. So we can get the ID by doing ID enter entities I. So in our concrete example here, we only have the tank. So what you're going to get is basically enter entities at index I is going to be 0. So our ID is going to be 0. There's only going to be one entity here because we only have one tank. Now for this entity, we want to create a Matter sprite. So we only want to do it one time. That's why we're doing it on enter, since we don't need to create a new Matter sprite every frame update. If we did it in query, it would be making a new sprite on every frame update. We don't want that. We only want it at the first time that these components are added to this entity. So let's go here, const sprite. So now we are passing in what we will pass in later from our scene when we create the system, the Matter physics factory. So matter.add.sprite. And we're going to give it an X, Y, and a texture key. So that's why we need our position component. So position.x index into ID. So our tank, as previously you saw when we added these components, we added it at index tank. Now we want to get the value back out at index ID, and our tank index is 0, and our ID here is going to be 0 because it is the only entity in the world we have right now is the tank. So that's how they match up. The entity ID is matched up here. Okay, let's just store this in X. Let's store this in Y, position.y ID. So that's how we get X and Y for our entity, X, Y. And then we want, let's call this texture ID, just like our position that we just did, Matter Sprite.texture ID. And then we're going to index into this textures array right here to get the texture key. So textures, texture ID. Okay, so now we've created our sprite. Now let's add our sprite to our map so we can reference it later. So we have Matter Sprites by ID dot set. So this is a map. So the key is going to be ID, and then the value is sprite, and that's all we have for enter. Okay, so let me just show you again if it's not clear what this index into ID is. So this index into ID is the same as this index into tank. So add entity produces an ID. In this case, there's going to be 0. And when we go through our system, it's going to go through it's going to give us back here in this enter entities list from on query enter. It's going to give us a list of all entities, all their IDs that adhere to this query of having the position and matter sprite components. So our tank fits the bill there, so it's going to be included. Now its ID is 0, so it's going to be in this list, and we get that value 0, that ID, from the list of IDs. Then we index in to the position components X and Y to get those values out. Same for the matter sprite component to get the texture index out. And then we use that data to create a sprite, and then we just save that sprite to this map so that we can look it up again later. Okay, now let's actually make our system here in our scene. Let's go back to our scene here. So we're going to create our Matter Sprite system. Now let's talk about this pipeline. In our arcade physics video, we did not use a pipeline. We just created all our systems and then manually called it in our update. Now we don't have to do that since bitECS has a pipeline feature. So all the pipeline really is you call this pipe function, and then for the simple case, all you need to know for this video is that it's going to call each system you put in here in the order that you've given it, so that you don't have to have references to every single system you make. You may make a lot of systems, and so this pipeline gives you a way to group your systems together, and they'll run in the order that you add them to this pipe function. You can use one reference to the pipeline and just call it like we're doing here. So let's do create Matter Sprite system. Right, so that's going to create a system. This function creates a system. We want to pass in the matter physics factory. So that's in this this.matter. Right, so this is the same matter physics factory that we want in the create matter sprite system function. And then we want the texture keys, which is this array that we've made. So what this means is we have a pipeline with one system in it, that's the Matter Sprite system, and then we're going to run it in update when the pipeline exists, and there is a world. So let's save this. Now let's bring over Chrome. Let's show you Chrome. Okay. Now let's just make sure that we have everything running here. Let's refresh. And there is our tank. So you see a tank right there. So we've did all the code that we needed to add a tank. This is a matterjs physics, so you can tell that is at least a physics sprite. because we have this debug on and it's this green box. So if we don't create the system, let's say we comment out the system here, you're going to see that our tank goes away. So no more tank. So we definitely need our system for this tank to show up. And if we don't add every component that we need, for example, let's comment this out, no Matter Sprite component, it will also not render since it doesn't meet the requirements of the system, of our Matter Sprite system. Let's add that back. So there we go. That is adding our Matter Sprite system and having it show up here. All right, so that's the basics of getting a Matter Sprite in a Phaser 3 scene with ECS. Now, if you enjoyed this video, be sure to hit like and subscribe for more videos on making games with Phaser 3, Matter.js, and ECS.